All right, in this video, we're going to look at the cotangent of t. And just like with the tangent of t, if we look only at the uh, points on our x and y axis when t goes around, it's not going to give us enough information. Because remember, the cotangent of t is the reciprocal of the tangent of t. So it is the cosine of t over the sine of t, or the x-coordinate over the y-coordinate. And so on this one, notice that when t is 0, when your angle is 0, this would be 1 over 0, so that's going to be a vertical asymptote. And then if I go up to 2 pi, I'm going to come back to this one in a second. If I go up to 2 pi, that would be the x-coordinate over the y-coordinate would be 0 over 1. So that's going to be 0. And then at pi, it would be negative 1 over 0, which would also be a vertical asymptote. And then at 3 pi over 2, it's 0 over negative 1, which is 0. And then back at 2 pi, of course, it's back at the same thing as 0. 1 over 0, which gives you a vertical asymptote. And so what we have here, when we draw it, is we're going to have a vertical asymptote here. And then we're going to hit 0 at pi over 2. Then at pi, we'll have another vertical asymptote. So it's going to look very similar to the tangent function as you would expect. And so this would be at pi. And then at 3 pi over 2, it hits 0 again. And then at 2 pi, we have another vertical asymptote. Now let's look and see what happens if I'm at a 45-degree angle. So in the first quadrant, remember it's 1, 1, square root of 2. And so the cotangent will be 1 over 1. And so that would be 1. So at pi over 4, which is here, it will be up here. So this one's going to go up like that. Or actually, it's coming down, but when we draw it, we'll draw it up. And then at 3 pi over 4, that would be in the second quadrant. And again, this would be negative 1 and 1. And so that's going to be negative 1 over 1, so it's going to be negative. So it's going to be down here. All right. And then if I go into the fourth quadrant, it'll be negative 1 over negative 1. And so it's positive again. And then if I go in the fourth quadrant, it'll be 1 over negative 1. And so it's negative again. And so notice that it looks a lot like the tangent function because it's a cotangent function. But remember, the tangent function started with a point on the origin. This one, the y-axis, is a vertical asymptote. So when you're looking at the cotangent function, it is going to be exactly the same, except for, notice this one goes down where the tangent function goes up. So let me just kind of plot in the tangent of t here. So remember, this one look like this. From 0 to 2 pi. This one is going down, so it's a decreasing function instead, and it's vertical asymptote on the y-axis instead of the tangent has a 0 on the y-axis. All right, so when t is 0, the function is 0 here. When t is 0, the function is undefined. And that would make sense because they're reciprocals of each other. So tangent and cotangent are very, very similar graphs. Now, if I want to shift it or anything else, you can do that just like you do with the tangent or any of the other graphs. I did want to point out, though, that if I do y is equal to the negative of the cotangent of t, it will be, all it's going to do is flip it over. And so it's still going to look the same. It'll still have a vertical asymptote here, here, and at 2 pi, and it would still be 0 and 0 at pi over 2 and 3 pi over 2. But instead of it going down, it will be an increasing function. Because what does the negative do? It flips it over. So now it really looks like the tangent function. So to determine between the two, what you're looking for is what's happening at the y-axis when t is equal to 0. The cotangent function has a vertical asymptote, and the tangent function has a point at 0 or at the midline. All right, so that's how it works.